here. We're going to get started, and I'm going to triage a little bit our schedule. What I'm going to be doing is to do a little bit more work towards introducing some of the basic concepts within AnyLogic. Specifically, we're going to build up a basic model from scratch. So we're gonna sort of build it up from the get-go. You've already seen some of that in the earlier sessions, specifically with respect to the building up a model with state charts and introducing some of the branches and state charts, etc. For this this particular session, we're going to build up a model which is a little bit more advanced, and you'll be able to follow this on a lecture here, which is called it's called Lecture 10, Introduction to AnyLogic Interface and Supporting Concepts by Building Up a Simple Model. Okay. So we're going to go through this. Hopefully a lot of this will be familiar. One point of feedback that I've gotten from researchers is that it's quite helpful if you have a chance to sort of repeat some basic tasks with AnyLogic. It helps remind you of how you go about undertaking certain types of duties. So that's what we're going to be shooting for here. Okay. So what I'd like you to do is to create a new modeling project here. Okay. So if we do File, New, and then Model. And specifically, I would like you to go choose a model, and I'd like you to name it. This is going to be a bit of a mouthful. Minimalist Network ABM Model. Okay. Let's see, Kurt, or maybe you or Aman, you can make sure, because I don't think Dr. Yu and Mohammed have had a chance to log in or whatever. So if you can make sure they get all set up. Thanks a bunch. Okay, so with this new model, I'd like you to name it Minimalist Network ABM Model. I'll do the same here. So Minimalist Network ABM Model, and I'll call it Boot Camp 2013, or I'll call it ABMB 2013. Okay, and you can again do it from scratch. That is, do it on a blank canvas. Okay. Now, what will we see after we create that model? Can anyone tell me? What will we see? So again, the steps here are within AnyLogic doing new model and then naming it Minimalist Network ABM Model. We start. What should we see for that model when it's first created? Okay, is person going to be there? Just going to be main and an experiment like this. Okay, you'll notice there's a star next to the name of the model itself, and that star indicates that it's modified. Okay, in other words, you've made some modification. It needs to be saved. In other words, if you want to preserve it. Okay, so I'd like you to create that new model, and now we're going to add an agent class in. So how do we add a class of agents to this model? Can anyone tell me? How do we add that class of agents? Remember we did that before? Yeah, we add the active object. Okay, good. So I'm going to finish this here, and we add an active object. That's step one, so that's very good. New active object, and then what do we add? what do we say for the object's name here? Let's make it person. So that's great. And then what do we have to do to make it an agent? We have to tick the checkbox for agent under its properties. Remember that? Remember that? Okay. Okay. Kurt, maybe you could help Mohammed, because he's also probably needs assistance there. So we have to tick the checkbox under the agent to turn into an agent. Remember, it's distinguished as an agent by this Da Vincian symbol up there. Okay? So we added that in, and we got person. Okay. So we went from something like this to something like that. That indicates person is an agent. What are the benefits of agenthood? The benefits are we can put them in networks, we can put them in spaces, we can send messages to them. There's lots of good things that can happen with agents that can't happen with just your average active class. And again, you'll notice there's a star next to it, so we should consider this saving this model. In general, as with most software, save early, save often. Okay, let's orient ourselves just a little bit with respect to the components of the screen. Okay. So the components of the screen are as follows. So up here we have a project window which lists this hierarchy of the components in the model. Okay. Here on the lower left we have a problems window, which basically you're going to indicate for us problems associated with our model, things that are preventing any logic from understanding its meaning, the meaning of this model. Okay. Over here to the right we have this palette that gives us a set of objects of various sorts that we can add to our model. These are components that add functionality to our model. And finally, we have the properties window down here, which allows us for a given selected item to set its properties. We've seen each of these components for the most part, with the exception of the problems window. It'll be very important that you keep an eye out on this problems window, because that's going to show you things that are potentially blocking you from making progress. Okay. One thing I didn't talk about this morning, but which bears note, is that by double-clicking on these windows, you can make a window full screen. So for example, by double-clicking on person, I can make it a full screen. And I can double-click on it again, it will be reduced to a normal size. Okay. That's useful if I want to do focused work on one particular area of it. In general, this runs atop what's called an Eclipse project, or Eclipse Interface, which is a very popular, the most popular interface probably within software development community. Okay, you can enable and disable windows through the View menu. Okay, and finally, sometimes windows can be minimized. So in other words, you can do minimizing of windows, and they will shrink down into a small piece, and then you can click on them and restore them. Okay. So just this is just learning your way around. Okay, so here we have the project window, and you remember we have main, which defines the stage in which the agents circulate. This defines the edifice in which agents move around. We have agent classes. There can be one or more agents. Here we have, for example, person, which might be one class, but in general we might have several classes for a given model. For example, we might have classes that are, you know, doctors and patients, or we might have cars and trucks and buses in a model of socio-transportation. We might also have agents associated with elements of a hierarchy. For example, we might have a city agent, a neighborhood agent, and a person agent, with separate dynamics operating at each of those levels in container relationships. In other words, a neighborhood contains people, and cities contain neighborhoods, etc., which might allow us to do, for example, multi-level statistics on some of the results of the simulation and compare them to similar statistics empirically. Finally, so we have these agent classes. There can be one or more of those. And then we have experiment classes, which define scenarios. They define the assumptions to use when we run the model. Okay? So main classes, agent classes, and experiment classes. Now, when I give this, I should note that each of these classes is associated with a visual representation and some behavior when you run the model. Okay, so it both has sort of a depiction when we're building the model, interacting with the model, and a depiction when we're running it, and a behavior when we're running it. So let's double click on person, for example, and we call up, we'll call up this canvas over here to the right. So double click on person here, okay, and we see this canvas here on which we can add properties. So what is this class? Well, this, when we say we have a person class, it's basically defining person. It's defining what it means to be a person with respect to our model. So, for example, if we say persons have, like this morning we saw that model, we had persons with 2 parameters, income and sex. That means personhood in our model is defined with respect to these characteristics, and then we associate them with state charts. So we say the person's dynamics in our model, the personhood is associated with 2 states, susceptible and infected, for example, and that people go between them. So an agent class defines sort of what it means to be an element of that. So what it means to be a person within a model. What is a person? What a person is. Now, a given class agent class will in general have many instances when we run the model. So there'll be many particular persons within our model. We saw that this morning, right? We had populations, each of them had multiple persons within it. And in general, a model may have many types of agents circulating in it. So multiple types of animals, multiple types of persons, different levels of a hierarchy, etc. Without going into a detail, this class is kind of like a mold that defines how do we cast particular objects. And those objects can have different characteristics. So it's like a cookie cutter we can use to produce multiple cookies. And then we can decorate those cookies with all sorts of different things. The cookies could differ from each other with respect to their details, but they all share the same general form given by the cookie cutter. So it is with a class. So we have persons, they're defined, their sort of characteristic behavior and properties are defined by person. The fact that they have an income, that they have a sex, that they have this sort of progression between susceptible and infective. But the particular details of a person can differ. They can have different incomes, they can have different sexes, okay? I don't want to belabor this point much, but it is important to recognize that each of these classes can then, of these agent classes, can have many particular so-called instances, many particular objects, as we say, associated with it that represent particular people. So this is Joe, this is Mary, this is Sam, and they differ with respect to the sex and income, for example, as well as their infection status. And in general, we've been seeing how we run this, how we can interact with this model, defining it, building it up at runtime, like putting properties in it, putting parameters and variables and state charts. And then when we run it, those particular objects, those instances, each have some behavior over time, okay? Again, I don't want to belabor this. Let's get on and go and start adding properties. So let's go add an oval to represent an agent, and we're going to do this with a little twist this afternoon, which will lend our model both some extra behavior, some extra power, as well as lend it some nicer visual appearance. So we double-clicked on person, we have person up, and now I'd like to add a visual representation of a person. Well, how do I do that? Who can tell me from this morning's session? I want to add an oval to be associated with it. Where do I go? Okay, so I'm in person. What do I do now to add that? Okay, good. So I go down to presentation here, and I can drag this over to here, right? Okay, good. Okay, now let's just to make it less overwhelming in size, let's sort of drag that, okay, and let's position it over here. Okay, so that's a good start. That's great. Now let's open up main by double-clicking on main. And this is the stage for the agents, right? And we're going to add in a population of these agents. How do we do that? Who could tell me? How do we add in a population of people? Where does it live? Where does that population live? Okay, it's a good question. This is the origin with respect to a person. It actually doesn't need to be there. It's just, let's put it this way. If people are going to have logical coordinates associated with them, okay? And it's most convenient often if they visually appear at the same visual position as they're logically located. And this defines their origin. So if we load it, if we were to move this to the right of it, they would have a logical position, perhaps, you know, at this point logically, but they'd appear at this point just over from that, which can sometimes be kind of confusing when reasoning about things. So I like to put it right at the origin. Does that make sense? Okay, good question. Any other questions there? Okay, suppose I want to add a population of people. How do I do that? Suppose I want my model to have a population of people. We're rehearsing this for feedback from previous boot camps, so we should rehearse these things. So how do I create a population of people? Okay, and where do I do that? Where does it live? Where does a population live? Sorry? Oh, okay, yeah, we could do it. We could do it that way, but I prefer to do things in a way that's step by step and clear. So I'm actually not going to do it that way because I want to do it from the ground up so there's a clear understanding of what's going on. There's actually a way to do it that conceptually to me is much clearer. How would and it's actually how I did it this morning. How do I add a population? Into what? In main. That's correct, yeah. So we go into main and then we drag person and we do population. Okay. Okay. So there's a population. That's good. So that's great. And I named it population. I clicked there, named it population. And suppose we want these individuals to be associated with some spatial layout. Well, we're going to indicate, we're going to indicate the replication and that it's 100 initial objects, okay? So I'm going to, there's a slight thing which should be updated with this slide based on the latest version of AnyLogic. So I'm going to just put that in there to remind me. Okay, so folks, if we want these people to be located in space, we're going to have to give an environment that will take care of them. So we're going to have to add an environment to sort of keep track of them spatially. So we have to drag an environment in from the palette here called environment. And then how do we make this population controlled by that environment as far as their location is concerned? Who can tell me? How do we make this population controlled by the environment? Good. Where do we add it? Yeah. Okay. We click on this population, and under environment, we say, hey, the environment is to be controlled by this particular environment. If we had called this thing env, we would have had to say env here. Okay? So in other words, we're saying the sort of thing that's going to take care of our location or spatial context, what networks we're in, is this, whatever the name of this is. Yeah. I need to speak with Scott about the icon for that. But the icon for environment. It has an odd resemblance to Barney the dinosaur.
It really does. It's like a blue dinosaur. That's awesome. Atlantic Ocean, I'm pretty sure.
Yeah, well, I was thinking about suggesting.
So blame the Atlantic Ocean for looking way Barney.
Anyway,
so what we need to do is we need to make sure that the procedure got purple and it makes better.
Yeah. Okay. So we added them in. So we should be able to run the model now. So folks, I'd like you to run your model. What should we see? Who can tell me? What should we see now? Who needs help here? Help? TA help? TA stand ready to serve. Okay, what should we see? We should see that. Remember that for this morning? Okay. Okay, but we're going in a different direction this afternoon. Okay, we've already seen the function of experiment classes. What's the function of an experiment class from this morning? You tell me. Folks, what does an experiment class do? What's the function of this thing that says simulation with an X next to it? So it runs the model with particular assumptions. It runs the model under particular, in other words, it defines a scenario of the model. It says, run this model with these assumptions as described by these parameters. Okay? So it tells the model a particular scenario to run. And in general, we'll have multiple experiments, just as we have multiple scenarios. Okay? Okay, I'm going to